let me tell you, I don't know if you remember, if you've looked through your notes or you've looked through the schedule or whatever from today, but you have a check-in, right? Right after this, over this material. So hopefully you've looked through these, but if you haven't, let's get our brains back in there because today is the day. Right now is the time. So for those of you that were here on Friday, we looked at this problem. Remember, we worked in some groups, we did some discussions. We looked at this one and the silly silo, and we did the silly silo. We finished that one on Friday. It's all recorded. So if you weren't here on Friday, make sure you watch it. And right now, we're looking at this one. It says Alice is driving on a windy road. One particular curve is completely flat and is a quarter of a circle as shown in the picture with the beautiful mountains over there. It says draw and label a Freebody diagram and write F-net equations to accurately represent the motion of the car. So on your purple sheet, this would be like number 2 or number 3, depending on where you're at, okay? And we could label this the car on a curve. And I did take a picture of the board that you all kind of rounded up with last time. So let's take a look at it. The forces that you've asserted are acting. The force of the earth on the car. Do you guys agree? Earth is acting for sure. The road is pushing on the car, perpendicular to the surface of the road. That would be a normal force. And then we've got the ground on the car or the road. I think probably I would make these two the same just so we don't get confused, right? So if it's the road on the car again as friction. And that one is pointing in towards the center of the circle, okay? We've said over and over that if you want something to go on a curve or in a circle, you need something to be applying a force, don't you? Because otherwise an object's just going to keep on with a constant velocity. Constant velocity means what? Can you remind me? What does a constant velocity mean? Yeah. Constant velocity means same speed, same direction. Remember, this is the one that we focused on for the first 3 months of the year. This is the one we're focused on right now. Because if you're going in a curve, you're not going in the same direction. And there is indeed some acceleration in the x direction. So I'm going to go ahead and draw that. If you have not yet drawn it, let's do it now. So this is the force of the road on the car. We decided that that was a frictional force, right? Keeping that car from slipping. Hopefully you have never had the experience, but you may have, of trying to take a curve when it's icy, right? And you go and you're okay, and then you hit that icy patch, and instead of being able to go around the curve, what does your car do? What does it do? It slides. Which way does it go? You want to go around the curve. Your car is here, and there's some ice right there. Right, so you were going this direction. That's your velocity vector. And where does your car end up going? Does it go around the curve? It does not. Where does it go? I can't hear you. Milo, can you put words to that interpretive thing? Go straight, right? Yeah, it's going to go in a straight line because there's no friction in this case to pull it over there, okay? We've got the force of the road on the car as a normal force and the force of the earth on the car as a gravitational force. What things are acting in the x direction? Be loud, you guys. Let's go fast. Friction! Yeah! Is it accelerating? Yeah! Which means that it has what kind of acceleration if it's going around in a curve? What do we call that? Centripetal. Centripetal. Yes, centripetal. All right. How about in the y direction? Is the car, is it going around the curve? Is it accelerating in the y direction? I hope not. Right? It's not flying up into the air. It's not sinking down into the ground. So indeed, it is not. We've got Fn. We've got Fg. We add those together, and it is 0. This is what I'm asking you to do on the check-in, okay? This is it. Make sense? Questions, issues, or concerns before we do that? Okay. All right, I'm going to give you 1 minute to go to your assessment seats. You need a pencil out. You do not need a calculator today. Just a pencil and your brains. You can leave everything where they're at. Question. Okay, I'll be right there. Hold on just a second. All right. So let me tell you what's going to happen now between now and the end of the period. And a reminder that today is going to be one of those split off days, right? So we're going to do half of you are going to do one thing today and the other thing tomorrow, right? So we're going to split halvesies. Okay. So group A is going to be doing the kind of work at your own pace, work on your own stuff problems. So let me just show you where this is so that you know what to look for. So you're looking at 2, 3, and 4 of 20 lab and learning days. This is the uniform circular motion. So group A is going to watch this introductory video. Everybody needs to watch it. Okay. It has information that we've not seen yet. So make sure you watch this video. And then there are a couple of problems in the book that are recommended problems to work on just based on those things. Okay. And the answers are available here just in a PDF so you can check your answers and make sure if there's anything that you need help with. Okay. Once you're finished with that, there are 4 different uniform circular motion problems that are quantitative. So this is standard 5.2. This is where we're adding the numbers to things. Okay. The questions are right here. I'm going to put them over on the table. Okay. And then there's another sheet with some more spaces for you to work on problems. Okay. Use the pink one because the pink one is the one that has the space for you to actually do the math. Okay. So I'm actually going to move these purple ones so I don't get confused. Okay. So this is the material that group A is going to be working on today. If you are in group B, you are welcome to take this and work on it tonight. That's absolutely fine, just knowing that tomorrow will be more of the same. But if you think maybe you'll need some help or whatever, or you want to get a head start, you're absolutely welcome to do this. I'm not going to like slap your hand if you take it, you know, if you're in group B, okay? But group A, this is what you're focused on. We'll be around to answer questions for you, okay? Group B are going to actually start the uniform circular motion lab, okay? And I'm going to go through this with group B people back in the corner and talk about how to set this up and all of this. This comes from the apparatus that we looked at on Friday with the design that you wrote on Friday, okay? I did not get those graded for you. And for my friends that were not here on Friday, that's you guys right here, right? I'm going to double check and make sure that you've got what you need so that you can do that part as well, because you'll get that done today in class. Okay, the design part so that you're ready to go. Okay. Questions that you have for me right now on the expectations for the day today, for the remainder of the period? Everybody's doing physics for the next 30 minutes. Okay, everybody's working together. All right. So let me break you up into some groups.